digital controllers already we have seen deadbeat controller. Today let us see Dhalin's design of Dhalin's. The deadbeat controller the assumption we made is for a step input. For a step input, the response is also a step response after one sampling period, after a delay of one sampling period, 1t. If dead time is there, 1t plus dead time. That is the assumption we made. The Dhalin's algorithm for the step input, the response is after one sampling period, it is like first order response with dead time. That is first order response, first order plus dead time response we are assuming. This is for Dhalin's. Therefore, the response y of s equal to y of s equal to what is the transfer function for this? 1 upon tau s, that is mu s. Mu is the time constant, mu s plus 1, that is the response. And it has a delay of theta. A delay of theta is there. That's why we can put e power minus theta s. Y of s equal to, this is the transfer function. Transfer function means output by input, or output you want means 1 by s. So this is the response for step input. 1 by s e power minus theta s upon, we know that what is the transfer function? Output by input. Output by input equal to transfer function g of s. Suppose you want output means what you have to write? Transfer function multiplied by input. That's why we wrote the transfer function for this response. The response of a system, this is the response of this system multiplied by r of s, that is 1 by s we got. Therefore, y of z equal to y of z equal to e power theta s can be written as e power minus k s approximated to k sampling period, where kt equal to theta, approximately equal to theta, ks upon z transform of mu s plus 1 multiplied by 1 by s. That is equal to z power minus k. For this, the response is 1 minus z power minus 1, the denominator. What is this? This is, after removing this, this is equal to s multiplied by mu s plus 1. We know that the z transform of 1 by s multiplied by tau s plus 1. For that, we know the z transform. What is that? The denominator, you will have 1 minus z power minus 1. In the numerator, 1 minus e power minus 1 by tau z power minus 1 divided by 1 minus e power 1 by tau z power minus 1. So we can write 1 minus e power minus 1 by mu, because sampling period t equal to 1. Here t by tau, this is t by tau, t equal to 1. Here also t by tau, t equal to 1. Therefore, 1 by mu e power e power minus 1 by mu z power minus 1. In the numerator, 1 minus e power minus 1 by mu multiplied by z power minus 1. This is y of z. Therefore, y of z upon y set point of z equal to y set point of z equal to 1 minus z e power minus 1 by mu s mu z power minus 1 1 minus e power minus 1 by mu z power minus 1 whole divided by this 1 by 1 minus z power minus 1 getting cancelled because y set point of z equal to 1 by 1 minus z power minus 1. That's why that is getting cancelled. Therefore, the remaining terms are z power minus k upon 1 minus e power minus 1 by mu z power minus 1. So this is y of z by y set point of z. Therefore, d of z equal to, we know the formula, 1 by h gp of z, y of z upon y set point of z whole divided by 1 minus y of z upon y set point of z. If you substitute all this here, what you will get is 1 by h gp of z equal to y of z upon y set point of z. Here, this value we have to substitute. If you substitute here, what you will get is z power minus k 1 minus e power minus 1 by mu z power minus 1 divided by 1 minus e power minus 1 by mu z power minus 1 whole divided by 1 minus z power minus k 1 minus e power minus 1 by mu z power minus 1 divided by 1 minus e power minus 1 by mu z power minus 1. If you take LCM, you will get d of z equal to 1 by h gp of z. If you take LCM, you will get this term instead of 1. Therefore, the numerator, what you will get is z power minus k minus 1. This minus 1 and this minus k you can combine together. You will get this 1 minus e power minus 1 by mu whole divided by 1 minus e power minus 1 by mu z power minus 1 minus 1 minus e power minus 1 by mu z power minus k minus 1. This is the formula to find d of z. This is the formula to find d of z.